welcome back to the Science House Express. I am Kim Gervase, and I'm the director of the North Carolina Science Olympiad program. I'm very excited to be chatting with Dr. Nelson Vinueza, an associate professor in the Department of Textile Engineering, Chemistry, and Science in the Wilson College of Science of Textiles at NC State. Nelson, thank you so much for joining us today.
Hi, Kimberly. Thank you for having me here, and glad to be on the interview. Like it.
So, can you tell us a little bit about yourself and about your areas of research?
Sure. First of all, I'm originally from Quito, Ecuador. So I came here in the US in 2003. I came to do my PhD at Purdue University. I did an organic chemistry, and then I did a postdoc on the area of analytical chemistry, both in Purdue. So after that, I decided to, make a transition from originally what I was thinking to do. It was as a chemical engineering background to do industry, but during my PhD, I changed to academia, and then later, I'm here. If you ask me when I started my PhD, I was going to be a professor. I like a lot and love teaching, but not exactly what I ended up doing later. So after that, during this time, I always have this freedom of, subjects that I like, and that was include forensics and all that. So while I was working on PhDs and my PhD and my postdoc, I always prepared for and have good mentors in forensics. And when an opportunity came to apply for jobs, that was an option. Then NC State came in, and I applied, did the process, and I was able to start my tenure track on 2013, and then I get my tenure in 2019, and now I'm sitting in the college as an associate professor, where it has been a lot of interesting work and ideas to do it, because the college himself is very interdisciplinary in many ways. But I think one of the great changes when I came as part of the interview was the Max Weaver dye library, which is a collection of 100,000 dyes. We have done some work with it. We have a high impact paper on chemical science, and that gave us a big push in collaboration with one of my colleagues, Danny Forches, in chemistry. And with that, what was the idea of that paper is to put dyes in general as not only things that give colors, if applying in different areas and different times, and ended up being so nice that now that the paper has able to launch several collaborations during with different parts in the US and different universities with this paper. So right now we have a strong collaboration with University of California, San Francisco, where we are working on dyes that can be used to detect the unfolding of proteins, for example. So these are things that were not, that was one of the ideas to expand the field. And now we're working on a couple of papers with that, and we just submitted a proposal with NIH, with our collaborator there. Then, we have collaborations with University of Texas, Arlington, University of Madison, Wisconsin. We have that too. We have also with MIT, we started doing some preliminary things with the library. So, at the beginning, that's how when we work on that paper of the dye library, see how color can be expanded in many ways. So that has been part of it. And then, of course, color as part of forensics. It's key, because if you see everything around, everything has color. If you have fibers or clothing, it has color. So it's one of the most important parts of forensics to determine what you have in you. So it's an interesting scenario. So if people see my webpage or my Twitter, so when they can see that, you will see that my work I put analytical, organic, and forensic chemistry, because it's very broad. But my main area of research is what we call mass spectrometry, which is one of the most versatile analytical techniques that allows me to work in different areas, specifically more like, dye characterization, instrumentation. We can do biofuels and new methods of development of detecting new drugs for forensics as well. Trace analysis of fibers that are 1 millimeter or less. So it's very different, that's one of the ideas. Because when we talk about trace evidence, we talk something that is very tiny and I think that's sometimes a challenge. So yeah.
So when you talk about, when you say dye library, of course, the first thing that comes to my head is the color palettes that are out at a Home Depot store where you go and pick your paints, right?
Yeah.
So can you explain what like what the dye library looks like? So it's a catalog, it's online.
So, so it's a collection of around 100,000 dyes that have been synthesized, and this was a donation by Eastman Chemicals that they gave us in 2014. So there are vials that have between, you know, a couple of milligrams to maybe 3 to 5 grams of each dye that has been synthesized, and there's not a specific order. It has been how the scientists at that time have done empirically. So, you know, and one drawer, and this is the College of Textile, so we have drawers, and I can send you pictures if you want something like that. I definitely do. So when you open a drawer, you have this collection of files, and depending on the drawer, you can have 600 to 1,000 dice in it. So you open, and you see a lot of colors. And you know, when I came first, and I was able to see the collection, as a perspective of a chemist, I see the color, but the vials have the structures wrote you know, by hand, so you can see that. So for me, that get my attention, like, oh, for me, dyes in a way are organic molecules that can be useful for a lot of different things, right? So when I see it's like, wow, this can be really nice. And that's why one of the things when we think about the paper, how these molecules can be useful for other different um, areas, not only textiles or just give, you know, color to walls or so. And then, you know, this collection is a historic kind of um, tells you about history about dyes, because we have dyes that have been synthesized around the late 50s, like 58, 59, that we have seen, out to 87. So you have a collection of how people have synthesized those dyes, right? And there's another part of the collection besides the dyes that have, there are fabrics that have been dyed with the dyes himself. So it's a collection of almost 250,000 fabrics that have been, small fabrics that have been done. We can see that. So that not many people know about that collection, but it's it's good because we can see how the dye behaves. And it's interesting because people, when you are not in the world of textiles, for example, there's something we call the fiber strip. So it's the same, you know, it's a piece of fabric that has different type of fabrics in the same one. So you can have cotton, polyester, you know, nylon and everything. And is when you do dyeing, and depending, you learn that for certain fabrics, you need a certain dye. That's one of the big things on it. When you put a dye and put this to a strip, you can see that sometimes it doesn't dye anything or stains, or, you know, the same dye gives you different kind of hues on the fabric. So it's interesting to see. So we have this on the collection too, on the strips and on the dyes, but on the purpose of dye chemistry, that allows you to see how the affinity of this dye is respect to the fiber. So you know, put it in different ways, the two collection allows to kind of have two areas of research. One to dedicate of characterization of dyes. One of the ideas that we are working in my lab is, for example, a lot of the things you see commercially are unknown structures, because some of them are patent protected, all other dyes don't. And when the patent is out, probably people get the structure, but sometimes you want to see what dye is, there's no information. So what we try to do is see if we get the molecule, put in the mass spec, fragmented, and with this fragmentation kind of created like a fingerprint of the dye, and see if it matches something that we have on the dye library or something that we have on our dyes with commercial. And that can help us to identify an unknown. This can be useful for the perspective of quality control, or it can be useful for forensics, for example. If we have a suspect with a red shirt and another, you know, the victim with traces of fabrics that are red, the reds are the same. First of all, the same fabric, yes. Yeah, yes, but then it's the same dye. And that's something that we can add a little bit more of, you know, you can make a little bit more individualization on that scenario. So the dye library, I always tell the person to visit the library, because it's something I like to do, is you have to see it. Everybody get their own experience, and you know, with people that have from companies and faculty that have visited, you know, for me, it's one experience. I see it in a way, but they get their own. So it has been a great, I think that has been one of the best, I would say, areas that I have been really focused on my research. And yeah, the library is just great.
And so can you check things out of the library, or is it only there for reference? So if I was a visiting professor or a forensic analyst from somewhere that wasn't NC State, how do I get access to the library?
Okay, yeah, that's a good question. And the thing is, it depends on the die, because the thing is, what happens is some of the dies that have a little bit of quantity. So in that scenario, it's less likely that you will have so much to do. But normally the process is, in a normal collaboration we do, is we are digitalizing the library first, which is a good step on it. That's what's part of the paper that we wrote in chemical science, was that we had to have a database that can be searched electronically, digitally. So then my colleague and friend Danny Forge came from chemistry. He has he does modeling and artificial intelligence and machine learning. So the idea was to create a way that if you are interested in a specific activity that has a molecule, on the digital database, can we see a similarity search of the molecule that you have in a 2D or 3D? And based on that, we have hits, we call them. And we can give you maybe the 10 hits that are the best, that represents the most closest to the molecule that you have, and see what happened on testing. So normally we give in milligrams quantities, because it's just for testing, right? And sometimes that's enough for what they need. And so when we advance, especially if we are in state, the only thing we do is the collaboration formally, you know, that we're working together. But in the case, for example, of University of California, San Francisco, we have you know, first of all, we have a confidentiality agreement because the structure are confidential in a way, but also confidentiality for the work they're doing. And then after that, if we had to give you some material, we do a material transfer that shows that, you know, what are the dyes are going to be used for and everything. So that's kind of an established process that we do. So that's normally we do. But in the case, for example, NC State, you kind of give us, we talk normally or write an outline of the research you want to do and quantities, and that we can help. So yeah, that's normally how it works. And yeah, it depends. There's times that we can have, you know, we can give you maybe 3 or 5 milligrams, and we can give you a little bit more. It just depends how much is on the vial. Is really what it is. And you know why I use mass spec, because I just need less than a milligram to see the dye, so I don't use too much anyway.
Right.
So you know, it depends on what the things we do. Yeah.
And so you were part of what we call cluster hire at NC State. And so can you talk about what that is, and then why that's so important that we have a multidisciplinary approach when we're doing our research?
Yeah, I think that's an interesting, you know, key question, because what you see now in academia in many ways is that the fields are starting to kind of get together in a couple of ways. And you know, sometimes I can have, the perfect example is Denis and myself, right? I do a lot of mass spec. He does modeling and machine learning and everything. So we combine together, and then he's also a cluster hire on bioinformatics. So, you know, one of the meetings of the clusters, we get together and we start talking, and that's how the paper actually came out. You know, we say, oh, we can do this. And that shows you that when you have that open mind to collaborate in a good way, there's two ways that you learn from one side and the other side. Stronger papers come, both collaborations and funding. You can apply more. And, you know, now we see also that a lot of the funding agencies are looking for multidisciplinary work. So I think that is key. And in the case of clusters, allows you to, you know, to see other departments help if you need it, and you can bring something to the table, and collaborations can come. So I think when a multidisciplinary collaboration is done properly, higher impact papers are come, and more possibilities of funding are created. So it's really nice to see this.
And I mean, it's true that none of us work in a silo, so it doesn't really make sense for you to be doing the same thing and you know, as another department, and not know about it. And then the in so much basic research, you don't know where the application for your research is going to land. So having more people at the table who are more well-versed in different topics, I think can only lead to better ideas and better research.
I agree. And you know, that's why I think I like forensics in many ways, because forensics, if you put it this way, forensics is one of the most interesting and more complicated areas that you can be, because there's expertise in any part of the you know, of the forensic field, right? From DNA to chemistry, toxicology. So you had to learn to talk to a lot of people at the same time and be aware, and, you know, and set up your limits and say, well, you know, when I'm teaching, yeah, I know about DNA and everything, how it works. But when they ask me something, you know, specifically, I give the name of my colleague that is in vet school, that she does the DNA and does forensics, you know, directly question, because I think that's the great thing, that we can collaborate in that sense, right? So sometimes when I'm teaching a class like DNA, yeah, I think I can teach it, but for me, it's better to call my colleague and say, you know, you're going to be a guest lecturer on it. I think you will do, you give another insight in, you know, what is the new tendency. And I think that's the beauty about, you know, multidisciplinary in many ways. So I think I like forensics on that, because you are not steady. You have to always learn, even if you, I would say, you know it, you know, the deep knowledge on that area is not your strength. So it's better to say, you know, this person can tell you more about it. So, you know, it's okay. It's good to see that from my side.
And I love that that I asked you to talk to me today, because we're interested in color this week, and we've done some experiments with some basic chromatography that you can do at home, but that we've really done a deep dive here into forensics. And so, what are some other careers that you can have if you go into color chemistry or an area like this?
So you know, the thing about learning about color chemistry is there are a couple of things, right? First of all, if you put it away, if you're going to create a new dye, you have to learn about synthesis. So you have to have some skills if you want to learn synthesis. That's organic chemistry, and also see how you can modify the dye himself. That can be helpful for different applications. That's material science. So you can create a dye that can have a certain, you know, a reactive a group that can help to do, for example, repelling and insects or so. You can do that because the molecule, for me, like I say, a dye is a molecule that can create color, depends on what you added into it. But then you can kind of decorate it with several things, right? And that decoration can have different applications. So, you know, where you can see dyes when you know more about this, you know, defense, because you can create dyes that can absorb IR. Imagine that you have a dye that absorbs, so you can become kind of completely, you know, they will not see where you are because your heat is kind of preserved with you. Camouflage, you know, all these things that people do. Then in the area, for example, of creating new, I would say one of people don't see it this way, but create a dye that after a while stays stable with photo stability. You know, it's nice when you have a nice shirt and suddenly you start seeing those colors like, oh, you know, it's those things, right? So how we create that? That's the synthesis. But then, you know, when you start spending the research, you know, our students, for example, in the polymer color chemistry program, PCC, what it does is interesting because they learn about fibers, dyes, finishing, and these things are things that we use in forensics. For example, if you have a fabric now that, you know, everybody has, you have to see that the shirt that I have has a dye. If there's a dye, what type of fabric is, because that's going to tell what type of dye is. And there's a finishing. So, you know, we can make cotton hydrophobic and polyester hydrophilic. We can change those conditions, right? So you have to have an interesting scenario for these things, right? So that can be another. Of course, you can go to a company that does color, develop colors, but you know, Apple, Google, all these companies are behind a lot of what you see in color, because everything you see has to be done with color. So it's not bad that you receive some ideas about, you know, companies interested in how the dye molecules behave. So it's an open, you know, it's interesting for me because it's a combination about knowing color and then, you know, make it, but also measure it. And also we have expertise on that. So there's a class that Dr. Renzo Shamey gives us in our college, and you know, about how to measure color. What is white is white, how we do that. And it's interesting because you start learning about how light influences the color you see. And it's nice because, every time, I don't know if you heard your mom or my parents or so, or your parents is like, when I was in the store, this blue didn't look like that. It looked different now, but when I like it, and it's just the light, how they play with that. So that is also about that. So, you got to have a nice interest about color. And of course, everywhere you see there's color, so there's something, there's a molecule, and try to get to that. It gives you an idea where color can be. The most important thing, blacks, for example, color black is interesting. A lot of people will not think that black is a mixture, and that happens. So, that's one of the most important experiments. You put a black and you start seeing different colors and determine which are the blacks. So, normally we have an experiment on the labs that I give you, um, 7 different blacks markers, and you see everyone is going to give you a different type of mixture. So it's nice to see that, right? And then the other sense is like, sometimes what happen is, companies, for example, imagine you have a shirt that you want to make it blue, and it not to be the blue. So instead of throwing that out to the trash, they put a mixture and make it a black. So, things like this can happen. And that's why sometimes, I don't know if people have experimented that you wash it after a while, it starts like being greenish or reddish, and they're like, well, it looks like that. And maybe, that happens. It's just a question of what happened in the process. So it can give you an idea what color is.
Well, and I don't think we talk about the clothes that they're wearing or what their favorite shades are and how much science has gone behind the color that is in the shirt they're wearing or their favorite pair of jeans. And you're right. I think we've all experienced throwing something in the washing machine and it coming out not the same color it went in, right? And so how those dyes set into your clothes and the quality of clothing and or anything that we do with colors. I think that's a great, especially when you think about people who are interested in fashion. There's a ton of science behind fashion. And I know I've seen that over at the College of Textiles many times. So important to think about that you might need a science degree before your fashion career.
And we have those, we have students that one of our students, she finished the chemistry polymer color program for us, the PCC. And then she moved to the TATM, to the other side, the marketing. Now she started doing an MBA and everything. So she has the whole world. So it's interesting, right? It's an interesting to see. For me, it was when she told me, I said, that's great because, I always tell as, one of the things I really like about the College of Textiles and in general is that you're an advisor for undergrads as well as grad students for sure, but see how they grow. And I always tell them, be free on that. And that's something that goes with me. It's like, if I'm interested in forensics, during my PhD in PI, my PI told me, I tell him, I'm interested in this class. I know, it's not related to my PhD. He said, no, take him. I know you're not going to take out for my research and everything, but that freedom, and then expanding your universe. So when I talked to this student, I said, sure, you are going to compile, it's going to be the perfect word because you will know the science beside, the scenes. And it's like, oh, where that's coming. So yeah, I think she's doing great, I'll say. And I'm glad that she did that.
Well, and I think just being scientifically literate, so she can read an article and understand what's behind it, or see some new emerging tech, or some sort of science that might help her company where she ends up. I think that's, again, that's that the multidisciplinary approach that we were just talking about. So she's going to be able to see the business side of how to get it to market and make a profit on something besides the science. So to wrap up, you're very passionate about your work. So what is your favorite thing about working in your lab?
To be honest, I think I like mentoring my students because, there's a part of mentoring. Of course, I show them how to some instrument works and how to do the science, but also make them grow in different directions. First of all, be open-minded, which is something interesting to do. And it's not easy because, one of the things I tell always my students is if you have a terminal degree, no matter what it's not that you stop learning, you have to keep learning. I say, that's what I think I like to be a professor because it's not steady for me. I keep learning and I see new things coming and you keep creating new things and everything and showing that to them. And then I would say uh, teach him how to write in a way, because write science is a little bit different in many directions. Be curious about it. Don't worry about it. Just go in and do it, and learn that wherever you go out, you're gonna go solve problems. So I think the mentoring is part of it. It's something I really enjoyed, and I think that is what makes me be a professor in many ways, because during this time, the graduate level is a little bit different because you pass more time with students. Undergrad's different because you have some classes, but it's the same way regarding when an undergrad alumni comes to you. You're just sitting. I sit in my office in the time, and someone knocks your door, and you'll just say that, like, and come and visit you, and then they tell you, thank you about this class, and I know, some helped me so much, and that's very fulfilling, and this is something that it really gives you more energy to keep going and going and going, So I think besides doing the science in my lab, the interaction with my students, mentoring them, I think is the most important thing that I really do and love to do in the lab.
I love that. And I'm ready to come sit in on one of your color chemistry classes.
Oh, you're more than welcome.
Thank you for joining me today, and I hope you enjoyed our chat with Nelson Vinueza. Join us next week when the Science House Express explores polymers. Until next time, be sure to like or subscribe to our channel, and additional information can be found in the description box below. Thank you for watching our Science House Express, and we'll see you next week.